All right. All right, thank you. So we're doing exercise 2 again, just for the recording. We're doing exercise 2. We're gonna throw a dice that has 5 faces with the numbers 1, 2, 3, 4, and 5. We're gonna throw the dice twice. So we have our diagram. This is the sector of the first diagram, so we can have a prime number or not a prime number. And then this is the sector of the second dice. Prime number, not a prime number. Prime number, not a prime number. Calculating the first probabilities is absolutely simple. We have 3 over 5 and 2 over 5. How? Well, the total faces are 5. 1, 2, 3, 4, and 5. We have 5 faces. That is the total. And 3 of those faces are prime numbers. We have the number 2, the number 3, and the number 5. Those 3 are prime numbers. So our probability is 3 over 5. In order to complete the sector, the probability of not prime is 2 over 5. Because those are the ones that are missing to complete the one, right? The 5 over 5, the 100%. Okay? Now, let's do the rest. Here, in the second dice, let's calculate the probability of getting a prime number on the second dice. Okay, so it is the same, right? It's the same. We have 3. Let me write this again. Bigger. Yes, 3 over 5. That is the probability of the second dice being a prime number, right? Same with this one. 2 over 5. 3 over 5. 2 over 5. Okay, now we have our probabilities. Now we can answer the questions, right? So the first part, A, find the probability that exactly one prime number is rolled. And now we have to think about which of all of these possibilities, all of these combinations, give us just one prime number. So the first combination, prime, is not good, right? Prime, not prime, this one is good. This one is good, right? Same with not prime and prime. This one is also good because just like this, we got exactly one prime number. All right? So that probability is 3 over 5 times 2 over 5, which is exactly 5 over 25. If I simplify this, this is 1 over 5. Correct? We can simplify this. Always remember, try to simplify whenever you can. Wait, this is not 6. That was a huge mistake. Sorry, I was adding and I needed to multiply. This is 3 times 2 is 6 and 5 times 5, 25. There, 6 over 25. For the second one, the same multiplication, right? 2 over 5 times 3 over 5. In this case, the multiplication is exactly the same, 6 over 25. All right, so what is the solution of question A? The answer of question A. The probability that exactly one prime number is rolled. It's just the addition of these two. That's it. So let me write it around here. I don't know if you can see it. A, yeah. 12 over 25. Remember, it is the addition of the ones that we care about. That's it. Beautiful. Let's jump into question B. Find the probability that at least one prime. We get at least one prime. So we can have one prime number or two prime numbers, right? Meaning, this is a good possibility, prime, not prime. And this is also a good possibility, not prime, prime. But also this one over here is a good possibility. In this combination, we have two primes. So let's calculate that probability as fast as possible. This will be 3 over 5 times 3 over 5. This is exactly 9 over 25, right? And now, the probability that we get at least one prime number is the addition of the 3 of these. So we have question B. B will be 12 plus 9, 21. So we have 21 over 25. Okay? That's it. 21 over 25. Now, from here, I don't even have to calculate this probability anymore. I know that this probability is 4 over 25. How do I know that? These three, the addition of these three is 21 over 25. 21, right? The denominator is 21. Well, I am missing 4 for the 25. So that is the one I'm missing right there. I don't have to do the calculation. Of course, 2 times 2 is 4 and 5 times 5 is 25, but I didn't have to do the calculation, right? I knew it from the start. Beautiful. Let's go to question C. Given that at least one prime number is rolled. Ooh. Given that, so we have a conditional probability in our hands. Conditional probability. Okay. For conditional probabilities, we always try to handle the condition first. Always. And in this case, the condition is whatever comes after given that. So the condition is at least one prime number was rolled. This is the condition, right? 12 over 25. This, no, at least, right? So this one, this is the condition, right? This is the condition. Okay, so we have the condition. We have our denominator already. Find the probability that 2 primes are rolled. What? Take a look at this. I don't have enough space. I'm going to have to do it here, all right? I'm sorry, guys. Let me see. How can I do this? Maybe like this. So I can split it. You guys can see it, sorry. Better, Maybe like this, I can split the board and you guys know what are the probabilities, right? And what is the work I'm doing. So let's do question C. Always begin with the condition, right? At least one prime number was rolled. So we know our probability was, the denominator is 21 over 25. This is the denominator, right? 21 over 25. How do we know that? Well, that is the answer to question B. At least one prime number was rolled. And what do I put here in the denominator, in the one on top? What do I put there? Well, that is the other part. What is it? Find the probability that 2 primes are rolled. 2 primes are rolled. So that probability is this one, right? 9 over 25. So that goes in here, 9 over 25. Now that I have this, all I have to do is cancel what I can cancel, and the result will be 9 over 21. 9 over 21. 9 over 21. Of course, this can be simplified, right? This can be simplified. If I simplify this, doing the dividing by 3, right? I have 3 over 7. Can you guys see it? Yes. So that is the real solution here, question C. That is the solution, 3 over 7. All right. For question D, again, given that, okay, so we have another conditional probability in our hands. I'm going to erase this part. I'm going to erase this part so that we can do that other one. So given that at least one prime number was rolled, again, at least one prime number was rolled. So we have the same denominator. Always begin with the condition. So the condition is the same as before, 21 over 25. And now the question is, find the probability that the prime number was rolled on the first attempt. The prime number was rolled on the first attempt. What is that probability? Okay, so it has to be this one, right? Given that at least once we have all of these options, find the probability that it was in here. So the denominator is 3 over 5. Okay. Cool. 3 over 5. What do we do from here? Just do the calculations. In this case, we cannot cancel the denominators. Look, 5, 25. They are not the same denominator. We cannot cancel it. But we can simplify. We can simplify, right? If I do the multiplications here, I'll have 3 times 25 over 5 times 21, right? And I can cancel some things. For example, 3 can be simplified with 21, right? 3 can be simplified with 21, right? So if I divide by 3, I'm going to have 1 and 7, right? And 5 can be simplified with 25. This is a 1, and this is a 5. So the final solution will be 5 over 7. This is the solution here for question D. 5 over 7. All right, pretty good, pretty good, pretty good, pretty good. Now, I would love to do one with replacement. I would love to do one with replacement. Hopefully you guys wrote this down, or if you didn't, we have the video, right, for that. But even though you guys are not asking, I want to show you, I definitely want to show you one exercise without replacement, because these are the ones that, oh man, these are the ones that are really, really good. Let me see where I can find this one without replacement. All right, let's try to do the first one. We don't have to do these ones, right? Oh, I don't know. Are we? Have we worked on these exercises yet, guys, or not? No? Thank you, Isa. Thank you, Isa. Both Isas. And thank you, Juli. All right, I'm going to do this one. I'm going to do exercise 1-8P, all right? That one is pretty, that one is, man, you guys are going to love it or hate it. If you like math, you're going to love it. If you don't, you're going to hate it. Pay a lot of attention to that one. You guys are going to love it. I am having a lot of fun, guys. I don't know if you guys can tell or not. I am having a lot of fun with this. All right. So, focus camera, please. Yes. All right. So we have a bag, right? And the bag contains 6 red and 5 blue counters. Let's say balls. It had 6 balls that are red and 5 balls that are blue. Maria Paz? You need to open the mic to tell me. What?
Nada, profe, estoy peleando sola.
Are you okay? You good?
No good, pero sigue.
Sure. Remember, if you have any questions, you can always ask me, okay?
Okay.
Okay, cool.
Bueno, profe, pues para ser sincero. Nada, profe.
Okay, so we have a bag. It contains 6 red and 5 blue counters, balls, cards, whatever you want. Count. I'm gonna say counters. All right. We are gonna choose one at random. So we are gonna introduce the hand in the bag, scrub there, and then grab one. Right? We are gonna write down the color. We are going to write down the color and then throw that counter. We are not gonna put it back in the bag. That's what it says there. We are not putting it back in the bag. We are gonna throw it. And then we're gonna select a second counter. So we go in the bag a second time and see the color. Did you guys get the idea of the exercise or not? All right, cool. Cesar, again, brother. Cesar, listen. You have a bag, all right? You're gonna go inside the bag and take out one counter. So far, so good, right? Cool. Take out the counter, see the color, see if it is red or blue, and throw it. Don't put it in the bag again. Cool? Then from there, go inside the bag and take a second counter. That's it. Okay, cool. So let's create our tree diagram for this exercise. And this is where things begin to get fun. Right, look at this. So we're gonna go into the bag twice, right? That's what we're gonna go. We're gonna go into the bag once, and then we're going to go into the back a second time. So we have our two sectors. The first sector will be the first time that we go into the back, right? The first time that we go into the back. And then the second time that we go into the back, right? First and second time. Now, if we go into the back, we have two options. We can have red or we can have blue. Correct? That is when we go into the back the first time. We could have two colors, right? The colors of the counters could be red or could be blue. Red or blue. And if we go the second time, we can have the exact same possibilities. We can have red, we can have blue, or we can have red, or we can have blue. Beautiful. That is our tree diagram. But now let's think about the probabilities. Let's think about the probabilities. All right. So what is the probability of getting a red counter once I go into the back for the first time? Okay, so what is the total amount of counters? We have 11 counters. Thank you, Isa. So the probability has a total of 11. Give me a second there. All right. We have a total of 11 there. And how many of those 11 are red? 6, right? So the probability of getting a red is 6/11. So far, so good. With the same analysis, we get the second one, 5/11. All right. Nothing new there, right? Nothing new. But now, guys, let's see. I want each and every one of you to write in the chat the answer to the following question. Yes, including Maria Paz. Each and every one of you. Tell me what is the probability here. What is the probability of getting a red in the second time, the second counter? What is that probability? In the chat, please. Remember, Isa, probabilities are between 1 and 0, right? So 6, not a good answer.
Yes, I send it again.
Okay, cool. Okay, we have some answers, all right? I am interested in Nico's perspective. Nico, what did you feel is the answer, brother?
I'm waiting.
Beautiful. Okay, I have a lot of answers now. All right. Don't repeat. Select one answer and put it in the chat. Don't repeat, all right? Don't repeat. Okay. Daniel, Nicolás, okay. Malu, did you answer already? Yes, okay, cool.
Yes.
Paredes, Poveda, did you answer? Paredes, I see you.
Sí, ya, profe.
En Poveda.
También, profe.
Okay, cool. So we're gonna drop it there. Now, a lot of you answered, right? I'm not gonna read each and every one of the answers. I just wanted you to show me what you thought. Now I'm gonna show you my analysis and you will tell me if you got it right or you get it wrong. Right? I see a lot of people who got it right and some others who got it wrong. This is analysis. Now, in order to calculate probabilities, we have to think about the total and then the success. But look at this. The total is not 11, right? It was 11 at the beginning, but look at the question. The question says, don't put it back in the bag. We are not going to put the counter back in the bag. Meaning, if I took out a red, there are not 11 counters, there are only 10. I took out one. So the total here is 10. That is the total. But what about the success? Okay, the success were 6, right? I have 6 red counters. No. Because I just took one. One of the counters was red. I took it and I put it away. So I don't have 6 red counters anymore. I only have 5 red counters. That is the success. So congratulations to the people who said the success was 5/10. Congratulations, guys. You did it perfectly. Isa, go ahead.
Profe, how do you know it was red? Because
Remember, Isa, we are calculating every possibility. So in here, we will write when when these are blue. So for the first one, we are assuming it was red. Cool. All right. So with that information, tell me this probability here. What would be the probability of getting a blue one? As soon as possible, please.
5/10.
Pretty good, Isa. 5 is the amount of blues, and 10 is the amount of counters in the back, right? In this case, we don't say 4 because we took out a red. So we know there are 5 in the counter, in the back, right? There have to be 5 blues in the counter. Same process with these ones, right? With these ones. The probability of getting a red. Okay, so the total is 10 in this case. The total is 10. Camera, please, this. The total is 10 because we just took out a blue one. We just took it. But how many are red? Well, 6 are red because the one that we took was blue. And for this one, again, the probability is over 10, right? The total is 10. But the success is how many? In the chat or open the mic, please. How many is the success in here? 4. Beautiful, Cesar. Beautiful, Isa. 4. Because we just took one of the blues. There were 5 blues at the beginning, and we took out one of the blues. This is a tree diagram without replacement. And this changes everything. Of course, the rest from here, the multiplications and all of the processes are the same. Let's do these multiplications as fast as possible. This one, the probability of getting red and red will be 30 over 110, right? All I did was the multiplications. Help me with the second one, please.
It's the same, right?
Yes, Isa. Beautiful. Help me with the fourth one.
Also 30 over.
Of course. And the last one. It's not the same, right?
20 over 110.
20
Beautiful.
over.
Thank you. Thank you, guys. Now, notice how the properties of the tree diagrams carry on. Look at this, look at this. Each sector, if we add these two, the addition is 100%. If we add this sector, the addition is 1. Look, 5 over 10, 5 over 10, that is 10 over 10, 1. This sector in here, if we add, this is 6 plus 4, that is 10. This is 10 over 10, also 1. And the probabilities in total, if we add all of this is 100%. Look, 30 plus 30 plus 30, 90, plus 20, 110. So 110 over 110, 1. How beautiful is that? This is a proof that we can do in our heads to see if the diagram is correct or not. Now let's begin with the questions. Now let's jump right into the questions. Let's jump into the questions. Man, I'm having so much fun. All right. Find the probability that exactly 1 red counter is chosen. Exactly 1 is this and this, right? So 30 plus 30. So the question A, 60 over 110.
Gus, tengo una pregunta, pero no es de eso.
Sure, Juanita, tell me.
Em,
You guys are in quiz. You guys. Sorry, Juanita, go.
¿La probabilidad frecuencial es la misma que experimental?
No.
Ah, bueno, gracias.
yes. I don't know.
No,
Look, it
Gus,
depends.
finish that exercise, please.
Sure, I'll finish it. I'll finish it, Majo. I'll finish it. But
Gus,
Okay.
Juanita, give me a second, Isa. Juanita, it really depends on the exercise and whatever the book or the page on internet you're looking for. All right, it depends on how they describe experimental probability and how they describe frequential probability. Now, I would say yes. Frequencies are the countings, right? That's a frequency. Whenever you count some things repeating, right? So I would say yes, that is an experimental probability. But it depends on the book, right? It depends on the page. Okay, Juanita?
Listo, sí, señor, gracias.
Cool. Now, before we continue, guys, you guys are in a quiz. Right now, you are in a quiz. So please, if you're living with someone, right now, if you can't do this quiz with someone, go ahead and do it right now, please. If you are alone or the person that you want to do it with is not present, you can stay. You can stay and we can finish this if you want to. All right? Now, that being said, Isa Olier, go ahead and ask me, please.
why 60 over 110? If the probability, well, the question says exactly one red candle, so it would be only 30 over 110.
Look at this, Isa, look at this. This combination gives me exactly one red. But also this combination gives me exactly one red. So we have two probabilities, right? And whenever you have this, we add.
Okay, thank you.
You are welcome. All right, lightning round. Let's try to do B as soon as possible. All right, find the probability that at least one blue counter is chosen. At least. So for blue, at least, we have 1, we have 2, and we have 3. So we add these 3. The addition will be 30, 60, 80. 80 over 110. Of course, I haven't simplified these. I haven't simplified the first or the second one, right? Have to do that. I have to do that. Question C. Find the probability that one of each color is chosen. One of each color. So we have red and red. This one doesn't work, right? Blue and blue. That one doesn't work. So we have this first, the second, and the third combinations as only possibilities, which is exactly at the beginning. 60 over 110. Question D. If one of each color was chosen, that's our condition. We have an if. That's a conditional probability. So one of each color was chosen, meaning this is the condition, right? What is the probability that the blue was chosen on the second pick? The blue was chosen on the second pick, right? So this over this, right? Let me write it here. 5 over 10 over 60 over 110. Do these calculations as soon as possible. And we have, this is going to take me a lot of time. 5 over 110, 60 over 60 times 10. We can cancel things here. Right? We can say 560. This is 11 over 60, 10. Cancel with this is 1 and 60, 12. 11 over 12. Lightning round. E. A, B, C, D, E, E. E. If at least one blue was chosen, at least one blue, so this option, right? This is at least one blue, right? Or is it? Yeah, at least one blue. What is the probability that the blue was chosen on the first pick? So this one, right? In other words, this over this. Beautiful. All right, so 5 over 11 over 80 over 110. Let's try to do these calculations again. So 5 times 110 over 80 times 11. Cancel what we can cancel, and we have, oof, man. All right, this is a hard one. This is 10 over 11 times, how much is 80 divided by 5?
5 over 8. It's the final answer.
5 over?
8.
Okay. Thank you, Isa. You are on fire today. Pretty good. But I didn't simplify these ones, right? I didn't simplify these ones. All right. Let me do it. So 6 over 11, 8 over 11, and 6 over 11. All right. Lightning round. All right. Beautiful, guys. If you guys have more questions and you are not gonna do the quiz right now, you can stay. You can keep on asking. We can continue doing these exercises. All right. I'm happy to do it. To be honest, I'm having a lot of fun. So we can continue. But guys,
Goose.
one of these days you're gonna say, "Papi."
Ay, Ruby. But los que no tenemos con quién hacerlo ahora, te lo podemos mandar después, ¿cierto?
Sure, but remember, you're not gonna send me anything. You're gonna upload it to Moodle.
Ok.
Y Gus, ¿hasta qué hora como
Tenemos-
por la tarde si no tenemos como alguien que nos ayude ya?
I don't know. I'm gonna leave it open all the day.
Listo, gracias.
Profe, ¿te avisamos los que no podemos grabarlo ahorita o no pasa
Yes,
nada?
I need to know. Yes,
Yo
I
no
was
puedo pasar.
expecting an email from you.
Bueno, ya
Teacher,
te
I
lo
cannot do it. I cannot do the video right now. I'm
Ok,
expecting
gracias.
an email from you guys. Okay. Thank you, Majo. Thank you. So, are you guys going or are you guys staying with me?
I'm staying, but can we do the next
I'm
exercise, please?
also staying. Yes.
Cool. Absolutely. Guys, remember, please be honest with yourself, all right? Be honest. I don't want to leave you homework. I hate leaving you homework. Doing the quiz after the class is a homework. So if you can do it right now, please go. Go do it right now. Be honest with yourself. But if you cannot, stay and we can do these exercises. All right, so the second one, right, Isa? Cool. Second one. And this. All right, second one. Let me erase all of these. Okay. So the question 2 says a bag contains 5 faulty and 7 working pens. So we have 5 that are bad and 7 that are good pens. Cool. Then a boy and a girl, each one need to take a pen. Okay. Okay, so let's say the boy goes first and the girl goes after the boy. Or should we do it backwards? Should we say the girl first and then the boy?
It doesn't matter, right?
Isa, man, you're on fire today. You are on fire today, Isa. It doesn't matter. It doesn't really matter. The probabilities at the end will be the same. Simply, the probabilities are multiplications. So it doesn't matter. All right, so let's do the diagram. We have the first possibility. We have faulty pen and working pen. Then the second one, we have faulty pen, working pen. Faulty pen and working pen. All right. Notice how in this case, I didn't put names for the sectors because it doesn't matter. It doesn't matter if it's a boy or girl. It doesn't really matter. All right? Now, if one of the questions asks us for the girl or for the boy, then we have to notice which is the boy and which is the girl. But so far, it doesn't really matter, right? The order doesn't matter. All right. So let's fill in the probabilities. We have faulty. So what is the probability that I took from the back a faulty pen? That is 5 over the total, right? But what is the total? Well, 5 plus 7, right? That is 12. So the probability is 12. Here, the probability is 12. I'm sorry, 5 over 12. The rest will be 7 over 12. Beautiful. For the second one, this person took a pen. This person took a pen. meaning this person doesn't have that pen. This is an example of without replacement probabilities, right? So what is the probability that we get a faulty here? Well, we only have 4 faulty pens because the first one was faulty as well. And the total is not 12. Again, we don't have 1 pen. So it is 4 over 11, right? Maria Paz? You good?
Señor,
Are you good? Ask me, Maria Paz. Ask me. If you don't want to do it, go ahead and in an email. Send me an email with, teacher, please, a tutoring. We can do it, just the 2 of us, all right? All right, let's continue. So, probabilities for, my marker. All right. Probabilities for faulty and then working pen. Well, if it is working, then we have 7 working, right? But we don't have 12 pens, we only have 11 pens. We just took out 1. Same with this one, faulty. So it is 5 over 11, right? There are 11 pens because I just took 1. And working, there are 6 over 11. I took out 1 of the working ones already. Beautiful. Beautiful. From here, I can do the multiplications. Let's try to do the multiplications as fast as possible. This will be 20 over, how much is this? 12, 1. Okay, that one is hard. 11 times 11, 121 plus 1. What am I doing? Plus 11. 121, 132. Did I do it correctly? 132? I have a mistake? 132. Yes? Thank you, Isa. All right. It's kind of hard to do this in my head. Sorry, guys. For the second one, 5 times 7 and then 12. All right, so 35 over 132. With this one, again, 35 over 132. Oh, 32, not 35. 32. And 42 over 132. All right. And we are done. That's it. All we have to do now is answer the questions. That's all we have to do now. Do you want me to answer the questions or can we drop it here?
Answer them.
Answer them. All right. But in what?
Together.
Together. Beautiful. Okay, let's do this one together then. All right, here we go. So A. Question A. What is the probability that both take faulty pens? So anyone, which one of these combinations is the ones that we are looking for? Nobody?
The first one.
Okay, cool. Thank you, Isa. The first one, right?
Hey,
It wasn't Isa?
Gustavo fui yo.
It was Malu.
Malu! You know what? You know why I cannot? You know why I didn't know it was you?
Because of the camera.
All right, so yes, we want faulty and faulty, right? What is the probability that both take faulty? So we're only looking for this first one, faulty and faulty, right? That probability is right there. Let me just write it. 20 over 132. But we can simplify, right? We can simplify this thing. This will be, if I divide by 2, this will be 10 over 150, 30, that is 15, 40, 60, 5, 66. 66? Yes, right? 66, 66, 66, 12, 66, 12, and 20. Yes, 66, right? But we can simplify even further, right? So instead of 10 over 66, let me write it here, 10 over 66, instead of 10 over 66, we can simplify even further. Divide by 5. Divide by 2, I'm sorry, right? So 5 over 33. Okay, 5 over 32. Question B. All right, question B. Find the probability that at least one takes a faulty pen. At least one. So how many of these combinations? Anybody?
Well, the first one, 20 over 132. And the other one, 35 over 132 and 30, and the one below that. The first three.
The first three. Beautiful. Why do we not accept the last one? Why is the last one not a good option?
Because it has both working pens.
We need at least one faulty one, right? Okay, so all we have to do here is add this, and this. Let's try to do it really fast. This is 35, that will be 70 plus 20, that is 90, right? 90 over 132. From here we can simplify, divide by 2. We have 66 in the denominator and 45 in the numerator. 66. We can simplify by 3. By 3, right? We can simplify by 3. 15 over 33, right? And we can simplify by 3 again, right? So 5 over 11. Hello, Malu. 5 over 11, okay. Okay, let's go with C now, question C. Given that exactly, conditional probability.
Gus, una pregunta.
Yes, Malu, cuéntame. Tell me.
En el quiz tenemos que simplificar.
Always. Especially
Okay.
now that we are working with this virtuality. Especially now that we're doing virtuality classes. Especially.
Ya que Malu pregunta algo del
Sí.
quiz, yo también tengo una pregunta, porque estaba, bueno, releyendo y se supone que tenemos 2 dados y no sé si saco 2 y 6, ¿qué número debo tomar en cuenta? ¿El más grande?
The greatest. That's what the instruction says. The greatest.
Ah, ok. Gracias, profe. Era eso, gracias.
Profe, ¿tienen que ser 2 dados? ¿No se puede solo uno y ya?
Isa.
¿Qué pasa?
Remember that you need to show me a diagram, right? And we have 2 dices for a reason. One sector and then another sector, right?
Yeah.
Profe, yo ya lo hice, ¿no te lo puedo mostrar?
No. No, I can't help you. It's your quiz, Malu. It's your quiz. I can't help you. You can listen, Malu.
Okay.
You can show it to your partners and see what they think about it. All right, let's continue with C. Given that exactly one faulty pen was taken, so we have one bad one. But exactly one, right? So exactly one means this and this, right? So now our condition is, remember, since we're doing conditional probabilities, we have the condition on the denominator. So the condition in this case will be 70 over 132, right? That is the condition. Now, how do I know that? Okay, this is a perfectly good combination for exactly one faulty, and this also is a perfectly good combination for exactly one faulty, meaning the probability is the addition of both. Okay, now, what is the probability that the girl took it? Girl. So we have to decide now. We're gonna have to decide. We are gonna have to decide. Which one and where, guys? For sector 1, boy or girl?
Boy.
Boy, beautiful. Boy. Which means the sector 2 is girl. Okay. We didn't need this at the beginning, but now we do. Now we do, right? We didn't need this at the beginning, but now we need it. Okay. Okay. So now that we have our total, let's think about the probability that it was the girl who took it. In which case do we find the girl taking it? Right? And, right? These two are probabilities, this one, 4/11 and 5/11. These two are probabilities that the girl took the faulty pen, right? So which one do we put? Which one?
Well, the sum of both.
Pretty good, Isa. Pretty good. So in the numerator, we will have 9/11. Now let me see if I'm doing this correctly. I'm thinking, what is the probability that it was the girl? All right, so girl and one faulty. Girl.
Goose.
This is a mistake. 9/11 is a mistake. And who can tell me why? Let's see if anybody can tell me why. I'm telling you, 9/11 is a mistake. But why though? Why? Nobody? Okay, my turn then. My turn. All right. It is a mistake because look at the question. The question says that given that exactly one faulty pen was taken and this option is two faulty pens. So this option does not qualify for our condition. We cannot take this one into account. We can't. The only option that we can take into account is this one over here, 5/11. That was a mistake. 5/11. All right. Remember, the condition makes our universe smaller. The condition changes our universe, right? So only the ones that qualifies are the ones that we are going to take into account. 5/11. Okay, if we do the multiplications here, yeah, I can't do this in my mind. Can anybody help me with this? I can't. 75. This
I
is
already did it.
how much is
6/7.
6/7.
Simplified.
Beautiful. Thank you, Isa. And that is it. That is the exercise. All right, pretty good. Pretty good.
Gus, tengo una pregunta
María Paz, ask away.
sobre el quiz.
Go ahead. Sure, don't worry.
Es de esto. Bueno, está grande. Bueno, pues es que no entendí muy bien. O sea, yo tengo que tirar los dados 10 veces, ¿sí?
Ajá,
Y
yes.
es de los dados, o sea, yo estoy jugando y está jugando en otra persona. Yo tiro los dados, ¿sí? Y la otra persona tira los dados.
Yes.
Entre esos 4 veces, o sea, entre esos 4 dados que se tiran, ¿sí? Pues de hecho son 2 dados, pero que se tiran, ¿sí? 4. ¿Sí? Tengo que mirar que de esos 4 el mayor número sea entre de 1 a 4. Si es de 1 a 4, gana el jugador 1. Y si es de 5 a 6, gana el jugador 2. Si esos 4 dados, el mayor número es 4, 3, 2, 1, pues gana el jugador 1, ¿sí?
Kind of. I feel like you have a mistake. All right. Let's do this. María Paz, do you have 2 dice? Beautiful. Okay, so let's decide. Do you want to be player 1 or player 2?
Jugador 1.
Beautiful. You are player 1, okay? You are player 1. Right. I am going to write down the points, all right? I'm going to write down the points. This is player 1 and player 2.
Okay.
Okay? And you are going to be throwing the dice. Cool? Now, you need to show us the answer. Don't lie. You need to show us the answer. All right, María Paz?
Pues, a ver, mira, ahí, ¿sí?
Cool.
Los voy a tirar.
But wait, I'm gonna stop the recording here because this is not This is enough
Yo
for the
lo
class,
tengo,
right?
porque yo la estoy grabando.